Hi guys. A few people asked about rationalizing a denominator, so I'm going to show you a few examples and hopefully that will help you. So basically, oh great, it's not writing. Let me just see if I can get it to write. Okay. So basically, you would have an irrational number in the denominator. Nobody really cares about the numerator. It's called rationalizing the denominator. So you're focusing on what's in the denominator. You just take whatever radical is there and you write it as a numerator and denominator or a fraction equal to 1. And then you just follow multiplication rules. So 3 radical 5 over the whole number 5. The whole purpose of this is so that your denominator becomes a rational number. That's why you're choosing two things that will end up equaling a rational number. So when you square a square root, those cancel because they're inverse operations. So that's always going to be the radicand. Okay. So another example, let's say I have radical 2 over radical 6. So again, I would copy the radical 6 and multiply the radical 2 over radical 6 by 1, radical 6 over radical 6. You multiply the 2 with the 6, that gives you radical 12. And then radical 6 times radical 6 is 6. Now, this is a lovely answer, but the problem is that the square root of 12 is not in simplest radical form. So we kind of want to do a little side work with that radical 12. That can break down into the square root of 4 and the square root of 3. The square root of 4 is 2. I have so much stuff on this. And the square root of 3 stays. So you end up with 2 radical 3 over 6. 2 radical 3 is simplest form for a radical, but not simplest form for a fraction. So you have to simplify the fraction to 6, which simplifies to 1/3. So you get radical 3 over 3. You can always use the calculator to help you simplify your fractions. Okay, so I'll give you 2 more examples. Let me just erase all of this if I can. Okay, so here's 2 more examples. Whoops. Okay. So let's say that I had the square root of 7 over the square root of 10. I would multiply by radical 10 over radical 10. That would give me the square root of 70 over 10. The square root of 70 does not contain any perfect squares, so it cannot be simplified. So that would actually be your answer. Okay, let's try one that's just a little bit harder. I don't know why that doesn't close. Oh, there it goes. All right, let's do 2 radical 3 over radical 6. So I would multiply by radical 6 over radical 6. That gives me 2 radical 18, because you're multiplying the radicand with the radicand, over 6. The square root of 18 can be simplified. I break that down into the square root of 9 and the square root of 2. Remember, you're always looking for a perfect square. So that becomes 3 radical 2. So I have 2 times 3 radical 2 over 6. 2 times 3 is going to give me 6. So 6 radical 2 over 6. Those 6's will cancel, and you're left with radical 2. Just a radical 2. If I could circle it, I would. Try and keep grabbing the calendar. All right. So basically the idea is that whatever you have here, you copy here as the numerator and the denominator. And then you multiply coefficient with coefficient, radicand with radicand, and then you simplify. You have to simplify the radical and you have to simplify the fraction. Hope this helps.